Hi and welcome to this Leaving Cert Higher Level Applied Maths video. This video we're looking at the 2025 exam paper, question 3, part A. So a block A of mass 8 kg and a block B of mass 4 kg lie at rest on two rough horizontal tables. That rough is important. It's telling us that we are going to have friction involved. The coefficient of friction between A and the table it lies on is mu A. The coefficient of friction between B and the table it lies on is mu B. So mu B is equal to 2 mu A. That's important. And the blocks are connected by a light, inextensible string which passes under a smooth, movable pulley of mass 12 kg. After the system is released from rest, the blocks and pulley move and the string has a tension of 32 newtons. Okay, and that's important. So tension of 32. So when the system is released, we can make a good assumption that these A and B blocks are going to move inwards and our pulley will move downwards. Bear in mind, when we have a system like this, the acceleration of one will be A and the second one will be different. So we call that B. And then the pulley in the middle, because it has two strings, is going to have an average acceleration. So that's A plus B over 2. It's always good to put that direction of movement on your diagram from the start because it is really going to help you. Even though the question didn't ask for it, what we're going to do is create some force diagrams to help us with this question. So here's our 8 kg mass, which is A. And the first thing that it has is weight, and weight acts downwards, and that's going to be 8g. The next thing we have is the tension in the string, which is pulling it to the right. We also have the reaction, which in this case, because it's lying on a horizontal table, is just going to be equal to the weight. The direction of movement is to the right. So there's our A. That also helps us understand that friction, which opposes motion, then must be going here. So our friction is equal to mu, and in this case, it's mu A times R. Okay, and for us, that's actually going to be mu A times 8g, because that's our reaction. Okay, for the pulley, we have 12 kg, so its weight is equal to 12g. It then has two tensions pulling it up, so T and T. And as we said, our movement is downwards, and it's going to be an average of both of the particles on the table. Then we have B, it's 4 kg, so its weight acting downwards is 4g. It's got a tension, which is in this case pulling it to the left. It then has a reaction, which is equal to its weight because it's on a horizontal table. Its direction of motion is to the left, and that means its friction is opposing motion. Actually, I might just pop the reaction on the other side. So that is 4g. So we have enough space to do our friction, which is mu R. So that is mu B times R, which is going to be mu B times 4g in that case. So then what we want to do is we want to create an equation for each of these force diagrams. So the direction of motion is telling us which way we're taking as positive. So for the first particle, we'll take the A, that's our 8 kg particle. We're going to have tension, take away the friction, which is mu A times 8g, and that is equal to ma. So we're using F equals ma. So the force, the resultant force is mass times acceleration. So 8a. The second one, let's do our particle B. So it's moving to the left. So bear that in mind. Now things to the left will be taken as positive. So we have T minus mu B for G is equal to mass, which is 4, times our acceleration, which is B. And then lastly, 3 is going to be our pulley. Our pulley is moving down, so we take down as positive. So that's 12g, take away 2t, and that's going to be equal to 12 times a plus b over 2. Now what we're trying to find is mu b. But remember that they actually gave us 2 bits of information that we can use to help tidy up a little bit. That is mu b is 2 mu a and tension is 32. So let's put in the tension. So that's 32 minus, here I'm getting 8g mu a, and that equals 8a. And here we get 32 minus 4g mu b is equal to 4b. And here we get 12g minus 64 is equal to, and I'm going to tidy that up as to 6a plus b to get rid of our fraction. Now, because we want to find mu b, it would be much better for us if we replaced mu a with mu b. So mu b is equal to 2 mu a. So we can rearrange that into being, well, mu a is equal to a half mu b. So we can put in a mu b in here with a half. So let's get ourselves some space and sub that in, and then let's work through the algebra. So that's going to give us 32 minus 8g and then a half mu b, which we're going to be able to tidy up as into 32 minus 4g mu b is equal to 8a. So let's take a look at the equations we're working with. So we have 32 minus 4g mu b is equal to 8a. We also have 32 minus 4g mu b is equal to 4a. 4, it should be b, 4b. And if you look at the left-hand side of both of those, you'll see that they are now equal. What this means from these two equations, we can say that 8a is equal to 4b, or 2a is equal to b. So that's an important little idea that we now have. So then if we come along to equation 3 is 12g minus 64 is equal to 6a plus b. Now, if I rearrange, or if I sub in instead of b to a, we now have an equation where we can solve for a. So let's get rid of that g, so that's our 9.8. So 12 by 9.8, that gives us 117.6 minus our 64. That's giving us 53.6. And that equals 6 times 3a. So that gives us 18a is equal to 53.6. Dividing both sides by 18 is going to get us to a is equal to 2.97 meters per second squared. B is then going to be 2 times that. So if we just double that number, we get 5.95 meters per second squared. We're still not quite there. We now need to go back and get mu b. Doesn't matter if we work with equation 2 or equation 1, because they're going to give us pretty much the same thing. So let's work with 2 because it's here. So we have 32 minus 4g mu b, remember that's the thing I want, is equal to 4 times b, which is 5.95. So if I multiply that by 4, that gives me 32 minus 4g mu b is equal to 23.82. So just giving us a bit more space, we get minus 4g mu b is equal to 23.82 minus 32. So mu b is going to be this answer. Let me throw in the calculator, divided by minus 4 times 9.8. I'll actually just put the whole thing in while we're going. So mu b equals 0.2086, so 209. And then in turn, we could work out our mu a if we needed to. So part two then asks us to calculate the acceleration of the movable pulley. So as we had on our diagram, the acceleration of the movable pulley is going to be the average of the other two, so a plus b over 2. That's our a and that's our b. You can change that to being a plus 2a, whatever works best for you. So our acceleration is going to be 2.97 plus 5.95, all divided by 2. This gives us 4.46 meters per second squared.